Hello and welcome to Unit 9, our final unit in this course. So congratulations for hanging in there. I know this has not been easy or ideal for anyone, but you've all been doing a great job. So keep up the good work, keep up the good effort. We're almost there, but don't give up yet, right? We still have a couple more weeks, so let's finish strong in this course. So I purposely did leave this unit to the end because I think it's one of the easiest units we have. It did used to be in grade 10 math. They changed the curriculum around a few years ago, and this unit actually used to be taught in grade 10. Now they've changed it, now it's taught in grade 11. And the other part that's really good is we finally use this formula sheet. So you probably forgot we even had this formula sheet. So right now, the ones on there with the quadratic formula we used, then the law of sine and law of cosine we used, and then that's it. We haven't used anything else. So you see all these formulas here, they all come from this unit. So what's that term you students like to use? Plug and chug. A lot of this unit is just finding the right formula, inserting the values, and solving. So should be a nice unit to end this term on. So like I said, make sure you have this handy. You're just finding the formula, inserting, and solving. We're still going to try and do it without a calculator as much as we can. And you'll also notice that there are two ways to solve these. You could even solve them without an equation. Sometimes you can just expand and see the pattern for yourself. But when you have your assignment, I do say you do have to solve algebraically. So I know that there's a longer way where you write it out, but this course, it does want you to be able to solve using the formula. So watch out when I ask you to solve for things algebraically, that means you do have to be using the formulas from the formula sheet. Okay, so today we're just going to look at the term sequence. So I know this word looks like arithmetic, but it's actually pronounced arithmetic. Don't ask me why. Arithmetic sequences. So page 6, we're right back at the beginning of the textbook, the very first chapter in this textbook for us. So an arithmetic sequence, it also is called an arithmetic progression. So I might use the term AP, and if I use that word in language, that just means an arithmetic sequence. They're the same thing. It's just a little bit easier to write out AP. That means it's an arithmetic sequence. Well, what do either of those terms mean? Well, the formal definition for an arithmetic sequence, or an AP, it's a series of terms in which each term after the first is obtained by adding a constant number, which we're going to call D, to the previous term. What does that mean? Okay, let's try some examples. We're going to look to see, is there a pattern? Is it an arithmetic sequence? If so, what's the D value? What number are we constantly adding to each term to get the pattern? So if we do some examples, I think that, and we reread that definition, it'll make more sense once we do this. Okay, so we have the example, 2, 4, 6, 8. Who do we appreciate? No. Okay, someone would have said that if we were in class, so I said it for you. So is this an arithmetic sequence? Is there a pattern? Do we keep adding a constant number to each term? And the answer is yes. So yes, this is an AP. It's an arithmetic sequence. We keep adding the same term. We're going to introduce some terms. You're going to see this T1, and the 1 is a subscript. T1 just represents the first term in our sequence. So the first term in our sequence is 2. Then what's the D value? What's the constant number we keep adding to each term to get to the next? Well, that is also 2. Does your D value always equal your T1? No, hardly ever. That's just one example I started with, an easy one. So like I said, this should be a nice, easy unit at the end of this course. So we're just looking for the pattern. T1 is 2. D is the value we keep adding 2 to each. Okay, let's try another example. Is this an AP? 2, 6, 10, 14, 18. Yeah, that's an AP. That's also an arithmetic sequence. What's the T1? The T1 is 2 again. That's just by coincidence. I don't know why I wrote my 1 like that. That's supposed to be 1. Okay, so T1 is 2. But our D value, what's our D value in this question? What number do we keep adding to each term? Well, that is 4. Told you it's not that bad. Let's do a couple more. Our next, oh, I didn't talk about this dot, dot, dot. When we see dot, 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 that just means that the pattern continues as it started. Okay, I just wanted to clarify that. 4, 1, negative 2, negative 5. Is that an arithmetic sequence? Yeah, it is. What's our T1? Oh, we're finally starting with a number that's not 2. We're starting with 4. Now, what's our D value here? Our D value is negative 3. So I know I said our D value is what we're adding to, but remember, you're adding a negative 3, so you're still technically adding. So your D values can be positive, but sometimes they are negative. Okay, and our last example, 1, 2, 4, 8. Is that an AP? No, it's not. there is a pattern. What's the pattern? We're multiplying each number by 2. But that's not an arithmetic sequence. For arithmetic sequence, you have to be adding by a constant number. So if you're multiplied by 2, yeah, that's a pattern, but that's not an arithmetic sequence. So that one is not an AP. There's no D value that you're constantly adding. Okay, so that's your introduction to what arithmetic sequences are. So today you're going to try and identify and recognize which ones are, which ones aren't, what's the T1 value, and what's the D value. Then, one other definition we'll look at today is something called the explicit formula. Don't worry, it's nothing bad. So in math, explicit just means that the terms are given as a function of which term it is in this sequence. Again, what does that mean? That feels like a bunch of words. What does that mean? Well, instead of giving you the pattern, they actually give you the formula. So for this one, instead of giving you the pattern, I'm going to give you the explicit formula. So this Tn equals 2 plus 3n, that's called the explicit formula. That means that I can find any term I want without having to find the previous ones. So the question says, let's figure out the first 4 terms and then the 10th term. So to get the first term, we replace n with 1. N just represents what term you have. So to get the first term, 2 always stays the same, 3 stays the same, but for the first term, our n value is 1. So 2 plus 3 is 5. Our first term in this sequence would be 5. The second term, again, the 2 and the 3 never change, but for the second term, our n value is now 2. So 6 plus 2 is not 9, that would be 8. Oh, I was so close to the end of the course. That is 8. Okay, for the third term, again, the 2 and the 3 don't change, but for the third term, our n value is now 3. 9 plus 2 is 11. To get the fourth term, again, these don't change, but for the fourth term, our n is 4. 12 plus 2, 14. Now, you can see the pattern, right? It was 5, 8, 11, 14. It's an arithmetic sequence, and we keep adding 3 to each one. So if you knew the pattern, you wouldn't need the explicit formula. So why do we have it? Well, it says find the 10th term. If I didn't have the explicit formula, to get the 10th term, I'd have to get the 5th, 6th, 7th, 8th, 9th, and so on. So if you're solving for like the 100th term, that would be really long if you had to solve for the first 99 to get to the 100th. So that's where the explicit formula is good. For T10, I don't need to solve for T1, 2, 3, 4 to solve for T10. The 2, the 3 stay the same. N is 10 for my 10th term. We have 30 plus 2, and that is 32. So that's where the explicit formula is helpful for that. Okay, so today should be a nice, easy lesson. You're just practicing some explicit formulas, determining your T1, your D value, and what's an AP and what's not. Like I said, hang in there, guys. We're near the end. Don't give up yet. Stay focused, stay motivated. We just have a few more lessons, and we'll be good. So hang in there.